Section 5.4 is entitled Compound Inequalities. If you dissect that word compound, compound to me makes me think of more than one, and that's exactly what compound inequalities are. Compound inequalities are two inequalities joined by and or. Let's first look at and situations. An and situation means an intersection of two things. And you will see later when we graph an and situation, it's literally the intersection of two different inequalities. Let me give you an example. X is greater than -2 and x is less than or equal to 1. So as you can see here, we have two inequalities making this a compound inequality. Specifically, this is an and situation because the two inequalities are joined by the word and. Let's look at the graph. I would first graph the x is greater than -2 by putting an open circle at -2, and it would go this way. I would then graph the x is less than or equal to 1 by putting a closed circle at 1, and it would go to the left. So you can see here, these two graphs intersect in between -2 and 1. Therefore, I could have just shaded in between the -2 and the 1 since it was the intersection of the two graphs. So I didn't need these lines up here at all. I could have just shaded in between the -2 and the 1 since any number that is greater than -2 but at the same time less than or equal to 1 would have to be between -2 and 1. So therefore, an and situation not only means it's an intersection but it also means between two numbers. You can write an and situation as one compound inequality, and in fact you are required to write and situations as just one statement, one compound inequality. So let me show you how that's done. The first step is to write down the less than inequality statement. So I'm going to write x is less than or equal to 1. Then what we're going to do is take the other inequality and we're going to flip it around. We're going to act like this less than or equal to 1 is not there and just think of it as x is something to -2. If I want to put the -2 over here, that means I need to flip this inequality sign around. So it's not going to be a greater than symbol anymore. It's going to be a less than symbol since I moved the x from the left to the right. So notice, again, I write the less than inequality first, and then I put the other number on the left-hand side and I flip that sign around. But really what ends up happening is you just end up with two less than symbols. So the arrow should always end up pointing in the same direction. And just to reiterate, you are required to write your inequalities as and situations as one compound inequality. Let's move on to or situations. An or situation is a union of two separate inequalities. So let's look at an or situation. X is greater than or equal to 0, or x is less than -1. Graph the smaller number first, which is actually the -1. So I will put an open circle at -1, and it would be going to the left since it's less than. Then we'll graph the greater than or equal to 0, so that would be a filled-in circle, a closed circle, at 0, and that would be going to the right. So notice it is two separate inequalities that are united as one compound inequality. That's where the union comes in. Notice also that they are going in opposite directions. And situations are in between, or situations are opposite. An or situation should almost always go in opposite directions. We'll see a few cases where they don't, and that would be a special answer. You cannot, I repeat, cannot write an or situation as one compound inequality like we did with ands. An or situation always says the word or. An and situation won't always say and. You will know that an and situation is an and situation because x is literally in between two numbers, and that's exactly what and means. X is between two numbers. An or situation, again, will always say the word or. Example number 1, translate the verbal phrase into an inequality, then graph the inequality. Part A, all real numbers that are less than -1 or greater than or equal to 4. So notice this says the word or. So this is an or situation. Although, don't get confused, if it's greater than or equal to, it also say or, but you should know the difference between if you're just talking about an inequality symbol or an actual or situation. So if it's an or situation, we know we're going to have two distinct, different inequalities. So all real numbers that are less than -1, so I would just write that as x is less than -1, or greater than or equal to 4. So x is greater than or equal to 4. I cannot write that as one compound inequality like I can and situations, so I'm just going to leave it as that and then graph it. So I would have an open circle at -1 going to the left and a filled in circle at 4 going to the right. Look at part B. All real numbers that are greater than or equal to -3 and less than 5. So remember, and means in between. So let's write our two inequalities and then we'll combine them into one compound inequality. So we'll first write x is greater than or equal to -3 and x is less than 5. So think about it. This number x has to be greater than or equal to -3, but at the same time less than 5. So it's going to be any number between -3 and 5. So to write it as one compound inequalities, start with your less than. So x is less than 5. And remember, it's in between. So you're literally sticking x between the -3 and the 5. In order to do that, I have to flip this inequality sign around. So it's going to look like less than or equal to x that way. So this is my actual answer, -3 less than or equal to x less than 5. Notice that x is literally sitting in between -3 and 5. So that's how your graph should look. So I'd put a filled in circle at -3, an open circle at 5, and again, x is in between, so I just shade in between. Example number 2, at an auction, the lowest bid for an autographed trading card is $20. The highest bid is $54. Write and graph a compound inequality that describes the possible bids. So the lowest bid of an autographed trading card is $20. So all bids, B, are greater than or equal to 20. At the same time, so and the highest bid is $54. So all bids are less than or equal to $54. So that means that all bids are in between $20 and $54. So this is an and situation, so I'm going to write it as one compound inequality. Write your less than first, so B is less than or equal to 54. Flip the inequality sign around from your original greater than and put the 20 on the other side. And notice it should make sense because we said all bids are between 20 and 54. So the bids are between 20 and 54. And it actually really helps to see that written as one compound inequality because you just put 20 on the left, 54 on the right, shade in between. Example number 3, an investor buys shares of a stock and will sell them if the change C in value from the purchase price of a share is less than -$3 or greater than $4.50. Write and graph a compound inequality that describes the changes in value for which the shares will be sold. So the shares will be sold if they are less than $3, or the shares will be sold if they are greater than $4.50. So we have an or situation. We cannot write an or situation as one compound inequality like we can with ands, so I'm just going to go ahead and graph it. So I'd have an open circle at -3 going to the left and an open circle at 4.5 going to the right. Now let's get into actually solving compound inequalities. So example number 4 says solve and graph. Notice that this would have to be an and situation because it does not say or. Remember, or situations always say or. And notice also that the x, though it has the times 3 and the -3, it is in between two numbers. So that is also a tip that it is an and situation. The way you solve and situations is whatever you have to do to get the variable by itself, you're going to do it to this number and to this number. So to get x by itself, I would first add 3. So I'm not just going to add 3 to the 24, I'm also going to add it to the 15. So I'd have 18 is less than or equal to 3x, these 3's are going to cancel, less than 27. So I would divide by 3 to get the x by itself. And again, I'm not just going to divide the 27 by 3, but also the 18. So 18 divided by 3 is 6, less than or equal to x, since the 3's will cancel, less than 9. So x is between 6 and 9. So when I go to graph it, I'll fill it in at 6, leave it empty at 9, and it's everything in between. Example number 5, solve and graph. We see another and situation since x is between two things and it doesn't say or. So again, I have to do everything that I would do to get the variable by itself on both sides of the compound inequality. So my first step would be to subtract 1. And I would subtract 1 from the left and the right. So I'd have 14 is less than negative 7x less than 49. I would then divide by negative 7. You should have some bells and whistles going off in your head because I'm dividing by a negative, which means I have to flip the inequality signs around. So I would have negative 2 is greater than x greater than negative 7. So be careful on this because when I go to graph it, the negative 7 is actually less than negative 2 on the number line. So I need to put the negative 7 down first, empty circle since it's not equal to, an empty circle at negative 2. So just make sure you have them in the right positions on the number line. And so it literally means that x is between those two numbers, so you just shade in between. And on to or situations. Example number 6, solve and graph. So notice that it says or. Every or situation always says or. And or situations are really easy to solve. I solve this inequality separately from solving this inequality, but I put both answers on the same graph. So let's get to it. First thing I would do is subtract 6. So I have 5x is less than or equal to negative 15. Divide by 5. I'm not dividing by a negative, so I'm going to keep the same inequality symbol. So my first answer is x is less than or equal to negative 3. On to my second inequality, I would add 8. So 2x is greater than 20. Divide both sides by 2. So x is greater than 10. So here is my answer. X is less than or equal to negative 3, or x is greater than 10. Again, this was one problem, just two separate inequalities, but I'm going to graph it on one number line. So I'm going to fill in the circle at negative 3, and it would be going to the left, leave it empty at 10, and it going to the right. And remember, or situations should typically go in opposite directions, just like this one is. And finally, one last or situation. Again, I know this is an or situation because it says the word or. So it's example number 7, solve and graph. I solve them individually and then graph them on one number line. So I added 1 to both sides, so I get negative 9x greater than 18. Divide by negative 9. I'm dividing by a negative, so I need to flip the inequality sign. There's my first answer. Then I'll add 12 to both sides. So I get 7x is greater than or equal to 21. Divide both sides by 7, so x is greater than or equal to 3. Put or in between my answers, and there's my final answer. To graph it, I would leave an open circle at negative 2, and it's less than, so it's going to the left, and fill it in at 3, and make it go to the right. As I said before, there are a few problems that are or situations that your graph might not end up going in opposite directions, and those are just some special cases which we will see in your homework. But this is it for this section. Make sure you jot down anything that you didn't understand so we can cover it in class, and we'll see you then.